Hi, my name is Timothy Atwell, and you're tuning in to the Division of Education, Innovation and Energy e-learning program. Today we're dealing with mathematics, and we're dealing with one of the most fun mathematics topics, circle geometry. The fifth theorem that we want to look at today, it really is not much to it, but it says that the angle formed between a tangent and a radius is going to be 90 degrees.
So this rule says that the tangent to a circle is always going to be perpendicular to the radius at that point. So here we have a tangent, and if we were to draw a radius from obviously the center of the circle to the point of tangency, then the angle made between the tangent and the radius is always going to be 90 degrees. So the angle made between a tangent and a radius is always going to be 90 degrees. The angle made between the tangent and the radius is always going to be 90 degrees.
So let's see if we can figure out the missing angles using the rule that we saw just now. So here we're asked to find angles A, B, and C. And let's see if we can recognize anything from this shape. So AB is a tangent. Why? Because it only touches the circle at one point. And we're told that the angle between the tangent and the radius is 90 degrees. So if the angle between the tangent and the radius is 90 degrees, let's look at this triangle. Triangle going from A to O, O to B, and then B to A. The sum of the interior angles of a triangle is equal to 180 degrees. So if here is 90 and here is 20, it means that this angle, angle A, must be the remaining, which is 70 degrees. And take out your calculators, take down your sheet, actually try to work them out. Because it is important that we have the ability, it is important that we have the courage and the confidence to be able to solve these questions. Now, we know that the angle here is 70 degrees. Let's see if we can figure out B and C. Well, what is this? This is a line that's going from the circumference to the center that has a special name, no? It's called the radius. So I'm just going to put an R there. Similarly, from this point C to here will also be a radius. So if we were to look at this triangle that goes from A to O to C and back to A, we would realize that this triangle has two sides that are the same length. What type of triangle is that? That's an isosceles triangle. And when it comes to isosceles triangles, the base angles are equal. So it means that, seeing that AOC is an isosceles triangle, and the base angles in this triangle will be B and C, it means that the angle B is equal to the angle C. And we know that when we add up all three, that should be 180 degrees, which means that these two must be equal to 180, take away 70, 110 degrees. So then each angle, seeing that they are equal, should be a half of 110, which is 55 degrees. So if B is 55 degrees, C is also 55 degrees. Let's look at the next rule. And it says that the straight line drawn from the center of a circle that is perpendicular to the chord bisects the chord. And the point where the line and the chord intersect is the midpoint of the chord. Let's see the video at this time.
So this rule, it says that a perpendicular line from the center to a chord bisects the chord. And what that means, if we have our chord here, this blue line again is our chord, and we were to draw a perpendicular line from the center to the chord, then this line this line right here is known as the perpendicular bisector. And this line will then cut the chord in half, cut the chord into 2 equal parts. So no matter the size of the chord, this line that comes from the center and cuts it at an angle of 90 degrees is going to cut it in half. So here we'll have 2 congruent triangles.
And again, before we move on, congruent means that the triangles are the same. So when it comes to this particular rule, we are actually making both similar triangles and congruent triangles. And now let's look at this particular example. Now this particular example seems a bit difficult because they're asking us for RSQ, the angle RSQ. And again, how do we determine what angle that is? We start with the points and follow to make the angle. So we're going from R, then to S, then to Q. So R, S, Q means that the angle we want to find is this one. So let's just give this angle a letter and we'll call it X. Now let's see if we can apply these rules to solve this question. So here, SQ is our chord. Yes? Great. So it means then that this line, PR, being a diameter and cutting SQ at 90 degrees means that this point is going to be a perpendicular bisector. And we said that as a result of that, this triangle, I'm going to call this triangle here, let me put this triangle here in red so that we could see a different color. This triangle, the red triangle, and we put the next one in green. So the red triangle and the green triangle are congruent or are the same. So if you can find this angle, it means that we know that this is going to be the same angle. Now let's go. How can we find that angle? Well, again, there are multiple ways in which we can go about solving for this. I'm going to show you the long way so that we can understand how we can develop the basic steps. And if you find other ways, feel free to share it with your friends and make them see how you could have applied it otherwise. It is great when you can help to develop and to see some ways that even I as a teacher may not have seen at the time. So let's go. We want to find this angle. So let's call this angle theta. Well, let's see how we can begin to find that angle. Well, we know here is theta, and here would be 90 degrees, because that is perpendicular. So in order to find this angle, we will first have to find that angle. So let me erase the board so that we could see clearly what I'm talking about. And let's go again. So we already established that if I want to find this angle, that this angle will be the same as that because these two triangles are congruent. So let's see if we can find this angle. Well, here we have a diameter, which will then mean that this angle here, subtended by the diameter, is going to be 90 degrees. Yeah? Which will make this angle how much? Well, 42 plus 90 is equal to 132. And then 180 subtract 132 is 48 degrees. So we know that this angle is 48 degrees. Now, let's continue. So now we know that this angle is 48 degrees. And we know that here is going to be 90 degrees. So how much is this angle? Well, 48 plus 90 is 138 degrees. And then 180 subtract 138 is 42 degrees. What? So this angle is equal to 42 degrees. No, I don't know if you see it yet, but this angle here being 42 and that angle here being 42, I'm giving you a challenge. Why do you think that these two angles are actually the same? I want to see if anyone can figure it out. And if you can, you will leave it in the notice board below. So, this angle being 42, we know that this angle is also going to be 42 because these are going to be congruent triangles. Because as the rule says, if a line goes from the center and cuts a chord perpendicular, it means that it's going to cut it in half. And that will then mean that these two lines, these two triangles will be congruent. It may take a while, but you will understand as you go along. Keep on practicing and you will get it. Now, I want to look at Theorem 7 and 8 together. And so we're going to go through Theorem 7, and then we're going to go through Theorem 8 and apply the both of them to one diagram to see how they work together. So Theorem 7 says that the two tangents that can be drawn from a circle, drawn to a circle from a point outside of the circle are equal in length.
This rule says that the two possible tangents from a point outside of a circle are of equal length. So the distance from the point of tangency to the original point is going to be the same on both sides of the circle. Because we know that every point will have two possible tangents, one this way and one that way. If it was on the next side, it would be one this way and one that way. If it was here, it would be one that way and one that way. Any point outside of a circle will be able to create two possible tangents. And we know, and the rule is saying, that the distance or the length between that point and the point of tangency is going to be the same on both sides. Now, if we wanted to join these two points of tangency, then here, from here to here to here, we have a triangle being formed. But not just any type of triangle. We have an isosceles triangle, which will then mean that the angle here will be equal to the angle here.
And let's look at Theorem 8, which says that the angle formed between the tangent to a circle and a chord at the point of contact is equal to the angle subtended by the chord in the alternate segment. So here we have the angle between the tangent and a chord, and that is going to be equal to the angle subtended by that chord at the circumference in the alternate or the other segment. Let's look at the rule and see if we can apply this knowledge.
The rule says that the angle between the tangent and a chord is equal to the angle subtended by that chord in the alternate segment at the circumference. So if the angle here is 50.2 degrees, then the angle subtended here would be 50.2 degrees. If we were to change the angle and it became 64.4 degrees between the chord and the tangent, then the angle subtended in the alternate segment will be 64.4 degrees. Now, let us say that this was now the case, where here, instead of us subtending the angle in the alternate segment, it is now subtended within the same segment. Well, in a case like this, the angle between the tangent and the chord is going to be the supplementary angle subtended in the same segment. So if the angle here is 70, then the angle here is 110. But if it's the alternate segment, then the angles are going to be equal. If it's the same segment, the angles are going to be supplementary. But if it's the alternate segment, the angles are going to be equal.
So let's apply these two rules in this diagram. We're asked to find the angles x and y. And we're only given 62 degrees all the way over here. Well, how do we do that? Well, again, we start from what we know. We know that 62 degrees is being subtended by which chord? Well, let's trace it back. The chord is at, one point is at A, I'm sorry. One point is at A, and the next point is at B. Means that AB is the chord that is subtending this angle. And the last rule we just met is saying that the angle subtended between a tangent, and why is this a tangent? Because it only touches at one point. So the angle between a tangent and a chord is going to be equal to the angle subtended by that chord in the alternate segment. So if here is 62, it means that x is also going to be 62 degrees. Now we want to find y. Well, we already know that here is 62 degrees. How can we find y? Well, if TB is also a tangent, it means that, as we already saw in the rule, that this triangle TAB will be an isosceles triangle. So if this side is 62, the base angle here must also be 62, because for isosceles triangles, the base angles are equal. So 62 degrees plus 62 degrees plus y degrees is 180 degrees. So to find what y is, we must first find out what is 62 plus 62, which we know is 124 degrees. Then to find y will be the difference between 180 and 124 degrees, which is 56 degrees. Good? Now I know it is a lot. The 8 rules are a lot, but it is important that you learn them and you practice. If you do not learn them and practice, then you will not be able to apply them. So again, I want to encourage you to take some time. Apply the rules, go them over, write them down, put them on sticky notes, put them on flashcards, stick them up in your room until you have them embedded into you. And then after that, you can apply any question going forward. So let's just look at some quick examples of some of the rules and see which rules apply to solve the questions that we have ahead. So here we have a diagram asking us to find A, B, C, and D. Can you determine what rule we should use to find any of these? Again, let's start with what we know. Well, we know that A is subtended by what? A is formed by that line. And what is that line segment called? Well, that's a diameter, because it's going from the circumference to the circumference through the center, which will then mean that this angle should be how much? What does the rule say? Any angle subtended by a diameter at the circumference is 90 degrees. So it means that A is equal to 90 degrees. Do we see any other right angle there? Well, let's look real hard. What about C? C is also subtended by the diameter, which will mean that this is also 90 degrees. And here, to find B, we have our triangle. So if here is 90 and here is 14, then we know that this must be the remainder to make it 180. 90 and 14 is 104. So then 180 take away 104. Quick maths, what's the answer? Beat it before me. Good job. It's 76 degrees. So B should be 76 degrees. Now what about angle D? Angle D is formed from this triangle. And if here is 16 and here is 90, then to find D, it's simple. 90 and 16 is going to be 106 degrees. So then 180 take away 106 degrees is going to be 74 degrees. So by applying our rule, in this case was just one rule, and our knowledge of triangles and interior angles of triangles, we were able to find all of the missile angles in this particular diagram. How about this one? What rule can we apply here? Well, this looks similar to the one before. And it's very important when you begin to see them. The faster you see them is the faster you can work them out. this angle is being subtended by this diameter. And because this angle is being subtended by this diameter, what is the value here? It's 90 degrees. Ooh, 90 degrees. Similarly, this angle is being subtended by the diameter. So what is the angle here, according to the rule? Any angle subtended by the diameter at the circumference is 90 degrees. And again, we work with our triangle. So here we have one triangle. Here is 90. Here is 32. That means this must be the remainder. And how much should the remainder be? I want you to work it out. Tell me if my answer is right or wrong. I say the answer is 58 degrees. But am I telling you that answer is right, or am I telling you that that's actually the wrong answer? Prove me right or prove me wrong. Try it right now. Take out a calculator, take out a little notebook and your pen, work it out. Get in the habit of checking the answers. Do not just look at the video and say that is the answer because sir said so. Sir is only human. I will make mistakes as well. Do not ever feel that I am the be-all and end-all of mathematics, because we are all learning as we go ahead. Did you check the answer? Is it correct? Let's just double check it. So we have 90 plus 32. Well, 90 plus 32 should be 122 degrees. And then we do 180, take away 122. That is going to be, we carry the 1, so we get 58 degrees. Oh, I was right, boy. Well, look at that. It just happened. What about the next question? We have 58 degrees, 90 degrees, and the next angle here. Well, this next angle is going to be 32 degrees. And I didn't even have to work it out. Why? You see, sometimes if you look at a question, the question will tell you the answer without even having to work it out. We just saw that when one side is 90 and the next side is 32, the next angle is 58. So if one angle is 90 and the next angle is 58, the next angle must have to be 32 degrees. And you didn't need to work it out. Do not think that it's just a matter of this step-by-step basis. See mathematics for what it is. Now, you may not get there now, and that's fine. Work it out if you must. But there is always room for growth. Do not ever feel that you have reached the pinnacle and that there's nothing more for you to learn. For if you reach that point, you will now become a fool. And we are not about bringing fools into this world. So let's go. One more example. One more example. An easy one. You think it's easy? I think it's easy. But let's see. So here they ask us to find a bunch of angles. A, B, C, D, E, F. That's 6 whole angles we had to find here. So this is looking crazy. And I know some of you all are now saying, sir, I don't understand. Hey, you don't understand yet. Let us take it step by step. Can we find any angle here? What do we know? Start from the point and let's see what we know. So here we have A. What chord is subtending angle A? Let's trace it back. So A is coming from this point and that point. Now, is there any other angle being subtended by that chord? Well, angle F is being subtended by that chord. And if two angles are being subtended by the same chord at the circumference in the same segment, we know that they are going to be equal, okay? So let's write that. So we know that A will be equal to F, and why? Because they are being subtended by the same chord at the circumference in the same segment. Now let's continue. What about angle E? Angle E is actually being subtended by that same chord. Look at it. If we go from E and we come back, we realize that it's going back to this same chord. And what do we know? The angle at the center is twice the angle at the circumference. So we don't know what the values are yet, but we do know that whatever E is going to be double whatever A is, or double whatever F is. You could choose. Now let's continue. Well, we know 92 degrees. Yeah? Well, what do we know about this 92 degrees? There are multiple ways in which we could work this out. But let's just take one right now. So this 92 degrees is being subtended by which chord? It's being subtended by that chord. And you know what? Let me just change the color so that we're not confused. Let's choose, what color do you want to choose? Let's choose red. Why not? So this red line is subtending the 92 degree angle. We good? So this angle is 92 degrees, which would then mean that angle D, seeing that it's subtended by the same chord, is going to be half of that value, because the rule says that the angle subtended at the center is twice the angle subtended at the circumference. So that D, we're back in green, so that D would be equal to 92 degrees over 2. And if we divide those, it is going to be 46 degrees. So we found that D is 46 degrees. Well, we found the value. We are good so far. Now, can we see any other rule applying here? Well, yes. Let's erase all of the chords that we've used so far and see if we could find a new one. And we're going to use blue for this one. This is the center of the circle as we've seen, right? Cool? Here, so from here, from the center to the circumference, what's that line called? It's a radius. So here we have a radius. From the center to the circumference, what's that line called? It's called a radius as well. So what then is this shape? It's an isosceles triangle. And similarly, we could have done the same thing here, because this is another isosceles triangle. So let's go. So we know that in an isosceles triangle, the baselines are equal. So if we know D is 46 degrees, so if we know that this is 46 degrees, it means that C is also 46 degrees. And if we know that these two are 46 degrees, then we can find E easily. I mean, we just have to do 180 take away 92. We could have done it from this straight angle here. We could have done it from this triangle here. There are multiple ways in which we could have done it. And after I finish this example, I want you to try it. See if you can find the values using a different method than I would have used. So angle E will just be 180 subtract 92, which is 88 degrees. So what have we met so far? We've seen what D is, we've seen what C is, we've seen what E is, and E is 88 degrees. Now, we know that E is twice A. So using this rule now, if we know that E is twice A, it means that 88 is double whatever value A is. So if 88 is twice A, then A will be a half of 88, which is 44 degrees. So this angle here is 44 degrees. And we know that A is equal to F, so that if here is 44, here is 44. So we've found A, we've found C, we've found D, we've found F. Now to find B. Again, there are multiple ways in which we could find B, but the simplest way right now is to see that this is an isosceles triangle, so that the base angles are going to be equal. So that means that A will also be equal to B. So if here is 44, there is also 44. It will take time, and it's important that you be and you be present for the tutorial sessions so that you can practice more with the tutors that will be here to help you to understand any theorem that you may have missed. If you need to look over the videos, there will be a link to the videos for the various theorems, and you could actually try and move them yourself and actually get the practice to see them in place. Please, Continue to work and you will get it. Continue to practice and you will get it. This is it for today, and I hope that you have a wonderful week. Be safe and have a wonderful time. Thank you.